So today's webinar will be on the topic how to migrate to a new age IT stack with KVM. We have our speaker Venko Muyankov who will be holding the webinar. And in the webinar, we will show you how to migrate your VMs to a new age IT stack with KVM step by step without interruptions and with a minimum downtime. Today's webinar will be approximately 40 minutes. We will start with a short presentation. Then we will follow with a live demo, which will be made from Venko. And at the end of the webinar, we will open the platform for questions and answers, questions from your side and answers from our side. One request will be, if possible, to mute your microphones during the meeting. Of course, you can unmute yourself at the end of the presentation if you want to ask the questions live. And during the presentation, you can type your questions on the chat. Just be sure that you're sending the questions to everyone who is in the meeting. And if we're ready, I can give the word to Venko. Venko is a solutions architect at Storpool Storage. He's very experienced in managing virtualizations, and he will share more about how to migrate to a new HID stack with KVM. Venko, it's your turn.
Thank you, Yvette. Hello, everyone. My name is Venko. I'm a solution architect at Storpool, and today I will make a short presentation about, actually not very short presentation, about a method how we can migrate a virtual machine from one type of hypervisor, we call it traditional hypervisors, to KVM, and how we can reduce the downtime during this migration. And then we'll have a live demo of this. We'll use a VMware for the live demo and migrating one Windows virtual machine to KVM hypervisor. So I hope we'll have some time after the demo for question and answers. Please send all your questions in the chat. Okay. Before start discussing the method, let's see some of the reasons to migrate to KVM. I guess most of you already have your own reason to do this, but still, maybe the most important one is that sorry, can you see my screen?
Yep, Venko, we can see it and we hear you well.
Okay, thank you. So maybe the most important one, the most important reason is that KVM is part of the so-called modern new age IT stack. All the latest technologies are mostly developed for the Linux stacks. For example, containers, automation tools, and so on. Also, if you run a modern IT stack, you can have easier access to a large number and highly trained experts that are currently working with this technology. All cloud-native applications are made with Linux and KVM IT stack in mind. Yet they might support other platforms to some degree, but Linux and KVM are native, and you get the best support and the most option with this. Linux and KVM being open source and with a huge community behind, you get with them a great flexibility and options for optimization. So you can set up your IT workflow to closely match your business processes. No vendor lock-in, this is clear. Software licenses, some use cases are very critical to the cost, and the license cost could be prohibitive to these use cases. For example, providing services on the, with the public clouds. And with KVM, you can get the same level of commercial support that you used to with your traditional vendors like Microsoft or VMware. And of course, there are some drawbacks. Maybe the most critical one is that if you're coming from other ecosystems, for example, from Microsoft, you need to gain some significant Linux knowledge. Support might be not as well developed as provided by the biggest vendors. And last but not least, having too much choice is not always the best. Probably if you have some limited choices, it could be better to help you, to guide you to the best solution. So let's first look at a high-level overview of a migration project, how such a migration project might look like. Before we go with this, I would like to make an important note. All the methods that we will discuss today assume that the virtual machines will be stopped at least once during the live migration, during the migration from one type of hypervisor to another. We will not discuss here live migration. For example, we will not discuss any sort of live migration from VMware to KVM or from Hyper-V to KVM. Of course, migration between the hypervisor of the same type would be live, but between different virtualization platforms would require at least one restart of the virtualization system. And with having this, the major requirement of a typical migration project would be to preserve as much as possible the virtual machine settings and the virtual environment when we are switching the virtualization platform, and to be able to do this with a minimum downtime for the virtual machines. So when we're switching virtualization platform, there are a lot of things to be considered and addressed. It could be, such project could be fairly simple, or it could be very complex depending on the specific tasks and what need to be migrated. But let's consider one such project, how it might look like. So first we need to migrate the virtual machine configuration and virtual machine settings. So we'd like to have the same or very similar settings for the virtual machines when we move them to the new platform. This includes the number of and type of virtual CPUs, amount of RAM, the number and size of virtual disk, network interfaces and virtual networks, any other virtualized hardware. So I would like to keep them as close to the original one as possible. Then any migration project would include migration of disk images. So when we start the virtual machine on the new platform, they will start from exactly the same state that they were when we stopped them on the original system. We may need also to migrate some of the storage system settings. So some storage systems provide different storage tiers or multi-tenant configuration or something like this that we may want to copy this to the new storage system. Typically, we will need to migrate the virtual networks with all the settings and the services the virtual networks provides. This is VLANs, addressing, routing, IP address reservations, also any firewall services that the virtual network provides, DNS, DHCP. Virtual network may provide some load balancers. So typically, we would like to migrate at least some of these services to the target system. Then we may need to convert also the users of the virtualization platform together with their access rights. Some virtualization platforms supports service definition, that is to group a number of virtual machines that provide a service together, and virtualization platform with these service definitions handles dependencies between these virtual machines and bring it up in the correct order. So if we have such a definition, we may need to migrate these definitions as well. Probably the most complex part is integration with the third-party systems. So typically we will have integration with some external systems like web portals, some automations, CI/CD, billing system. We may have some provisioning system, inventory management system, so many other type of systems that could be integrated with our cloud. So we need to address this very carefully during the planning phase. What type of integration we would like to migrate to the new system. And some virtualization platforms also provides services like backup of virtual machines, images and configuration, disaster recovery, site management, and so on. So we may want also to address these services. So as we can see, there are a lot of stuff. We cannot cover today everything. Today we will cover the most basic aspects of the migration, but mostly the most important one: migration of the virtual machine configuration and virtual machine disk images from the source system to the target. And today we will see how we can do this migration with minimum downtime. For the demo today, we will have one VMware ESXi hypervisor that is connected to shared block storage over iSCSI, and on this block storage are stored the disk images of the virtual machine. We will use one Windows Server 2019 virtual machine for the demo, and we will migrate this virtual machine to a KVM hypervisor. This hypervisor is orchestrated by OpenNebula, but there will be nothing specific to OpenNebula in this demo today. So exactly the same method can be used with any other KVM-based orchestration like OpenStack or CloudStack. So we will use again shared block storage for the destination storage. In this case, it will be store pool, and we'll store the destination disk image as raw disk images. So the usual approach when we need to migrate a virtual machine from one type of hypervisor to another might look like this. So we start with the initial setup where we have a source virtual machine running in the source hypervisor on the source virtualization platform, and it is using its disk image. So typically the first step would be to define a new virtual machine on the target system with the same or very similar settings as the source virtual machine, and to define a new empty disk image as a target disk image that is the same size as the source disk image. Then the next step is we usually stop the virtual machine to ensure that the content of the source image is consistent, and we can start copying the content of the source disk image to the target disk image. When we do this transfer, we need to be sure that there are no write operation on the source image, and that's why we typically stop the source virtual machine. This process, transferring the data to a target image, could be very time consuming, especially if we have to transfer large disk images over relatively low bandwidth links. This step is usually the longest one, and this is the main contributor to the downtime during the migration process. Once the disk image content is transferred, the guest operating system needs to be updated with the new settings, and most important, to be installed the new drivers for the new changed target hypervisor. This is required because the new target hypervisor would typically provide different type of virtual hardware, and these drivers might not be installed in the guest virtual machine. So before we start the virtual machine for the first time on the target hypervisor, we need to install the drivers for the new virtual hardware on its image. So we call this osmorphing. And The other step here is we may need to change some of the settings of the target virtual machine, and these are caused, for example, if we need to use different services, different names or addresses that are provided by the new cloud. So these settings reflect the change of the environment where this virtual machine will work. When we are ready with this, we can start the target hypervisor and to the target virtual machine on the target system, and to start using the migrated disk. So this is the basic process of the usual approach. As you can see, it may cause significant downtime, and let's see how we can improve this process. And the demo today will be on this process that is significantly improved over this traditional approach. So we'll start with the same setup as the original one. We have a source virtual machine running on the source system. We have one virtual disk image. The first step is the same as the previous one. We create on the target system a virtual machine that is with the same or similar settings and one empty disk image. But now, instead of stopping the virtual machine, we'll create a snapshot of the disk image on the source system. When we take a snapshot, the disk image with entire disk content is frozen. This image is now used by the main image is now used by the hypervisor only for read operations, and all the writes goes to a separate image, separate disk image. So this allows us to start transferring the majority of the data, so the entire disk image, while the virtual machine is still running. And because this image is frozen, we are sure that the data we are copying is in a consistent state. When the image is fully transferred, we continue as usual with stopping the source virtual machine, and then copy the snapshot image to the target virtual machine. So this snapshot image, is much more smaller than the original image and can be transferred very fast. The unique step in this process is applying the snapshot that we have transferred to the new image. The difficulties here comes from the fact that we have created this snapshot image on one type of hypervisor and on one image format, and we need to apply it on a different image format. So in the case with our demo, we have created this snapshot image on a VMDK image format, and we have to apply it to a raw disk image that will be used by the target hypervisor. To do this task, we use open source tool that we have developed. I'll go through this in more details during the demo. And after we are ready with applying the snapshot, now we have a completely synchronized copy of the source image. Then we can start with osmorphing as usual. And when we are ready with this, we can start the target virtual machine on the target system. So this is the theory. Let's start with a demo, and I'll try to explain every step during the demo, how it can be done and what are details here. So the tools that we will need for the demo are QEMU image. We use this tool to convert the initial VMDK image format to a raw image that will be used by KVM. Then sysparse, this is the open source tool that we have created that can read and process VMDK images and can apply snapshots created by VMware on raw images. You can find this tool in our GitHub repo. And the last tool that you will need is virt-v2v. It is part of libguestfs project. This is a very huge project. and this tool, Vert V2V, is used to make changes on the disk images without need to spin off virtual machines. So with this tool, we'll be able to install Windows drivers and change settings without need to start Windows virtual machine on the target hypervisor when we move the disk image. So this is the demo setup. Again, we have one ESXi hypervisor with one virtual machine running Windows here. It's disk image in the VMFS data store. KVM hypervisor with a target virtual machine that will use shared storage for the disk images. And we have one more virtual machine, we'll call it here conversion virtual machine. This is a Linux virtual machine that has all tools needed for the migration installed there. So we don't need to install any third-party tools on our KVM hypervisor. So with this virtual machine has access to the source and target storage system. To the source system, it has access through the ESXi, and we will do all the migration tasks from this conversion VM. So when we transfer the content of the images, we will disconnect the destination or the target image from the conversion VM and attach it to the target VM, and we'll start the target VM. So let's begin. So this is the source hypervisor. And this is the virtual machine that we will migrate. Let's start it first. Okay, so this is the initial state. We have a hypervisor with a running virtual machine. As you can see from the settings, we have 2 virtual CPUs, 4 GB of RAM, 20 GB hard disk, 1 network controller connected to one of the virtual networks. And this is the destination system. This is the OpenNebula web interface. We will use OpenNebula to manage the hypervisors. So I have created here one virtual machine that is with the same settings. Let's check them. So we have 2 virtual CPUs, 4 GB of memory, and we have defined one virtual network interface to the virtual network connected to the same virtual network that's available in VMware. So for the storage, we still don't have a virtual disk defined for this virtual machine. We'll do this in a minute. How we can do this? So it depends on the target orchestration system. So there is no universal recipe for this. It depends on the source system and on the target system, and also what type of services and what type of configuration you would like to migrate to the target system. So this is specific for each individual case. So now we will create, okay, let's check for again. So we will define a virtual machine at the target hypervisor, and we will define also the empty disk image. So let's give it the name, disk 1. Select the data store. We will create an empty disk image of the same size, 20 GB. Okay, this should be enough. So these are specific settings for the OpenNebula, but basically you can do this with any KVM orchestrator. So our image is ready. And the next step is to take a snapshot of the virtual machine disk on the source hypervisor. So let's get back here. So we can do this from VMware web interface. But on the demo today, we will use only CLI tools from the migration or conversion virtual machine. This way you can see how you can do this and how you can automate this process. So here we have this shell session to our conversion VM. We have here all the tools that we need already installed. And we have SSH access to the VMware ESXi server from here. Okay, so we can execute commands from here. Okay, I'll get back to our conversion VM. So all the commands we will execute on the ESXi will be run through SSH from this host, from the conversion VM. So we need to take a snapshot of the disks of our virtual machine. Let's first get a list of all the virtual machines that are defined on our source hypervisor. So the command is to get this, to get a list of virtual machine is this, and to execute it over SSH to the hypervisor. So this is the list of the virtual machine defined in our source hypervisor, and this is the virtual machine that we will migrate. So we will migrate a virtual machine ID 95. So before we create a snapshot, let's first see what are the images that this virtual machine has. So again, we list the images through the ESXi, and we can see we have 2 images. Actually 1 image, 2 files and 1 image. So this is the main image. Its size is 20 gig, and it contains all of the content of the virtual disk. And this small file, only 500 bytes, this is the configuration of this virtual disk. So when we create a snapshot, so this is the command to create a snapshot, to take a snapshot. And we'll execute this command on the ESXi. Okay. So let's take the snapshot. Here it is. And now we can see that we have 1 additional image. So this is the snapshot image that was created when we took the snapshot. The original image is still here, but now it's frozen. There are no any writes anymore to this image, and all the writes goes to this new image. We'll call this snapshot image. So let's get back to our list of steps. So when we took a snapshot, we shall copy the original disk image to the target hypervisor. Again, we'll do this from our conversion VM. So I will use SCP to copy this disk image. In practice, you may use other protocols. For example, if the disk images are on a shared file system, you can directly access the file system, or you can access this over iSCSI or any other type. But I will use SSH in this case and SCP. So let me first copy the configuration file because I'll need it as well. Okay, and the big one. Okay, so it will take about 3 minutes to copy these 20 gigabytes of data. And meanwhile, let's look at with more details how our virtual machine looks like. So let's log in here. Okay. So let's check the virtual machine configuration. We have two virtual processors. The ESXi hypervisor exposed them the host processors that are i3 4170 at 3.7 gigahertz, 4 GB of RAM, and the more interesting stuff is here in the device manager. So let's see what are the virtual hardware that we have. So first, the virtual disk is VMware Virtual SCSI disk. This disk is connected to a SCSI controller. In this case, VMware emulates LSI SAS 3000 SCSI adapter. When we migrate this virtual machine to KVM, this hardware will be changed to VirtIO SCSI adapter, and this will be changed to QEMU virtual disk. The other hardware that also will be changed is the network interface. Now VMware emulates Intel E1000 network controller, and when we migrate it to KVM, KVM will expose a paravirtualized network interface that is using VirtIO net driver. So in order to be able this virtual machine to boot, first we need to install VirtIO drivers for the disk, so it will be able to use the root disk, and then we need to install VirtIO network drivers in order to be able to use the network. And this is part of the osmorphing step, one of the last steps in the process. Okay, let's check how our transfer is going. Okay, we have 40 more seconds to transfer the source image. Okay, we're almost ready. Okay, this was the longest step. So let's get back to our list. Once we have this image content transferred, we have to convert the original disk image format to the target image. So in our case, it will be raw image format. And we have to convert this VMDK image to raw image. To do this, we first need to attach our empty destination image to the conversion VM. So let's get back to Open Nebula. And this is the empty disk that we have created. And we'll attach it to our conversion VM. So here in storage, attach disk and attach this image. Okay, and now this image is attached as SDB drive in our conversion VM. So let's get back in the conversion VM, and here it is. We have a 20 gigabyte disk image, and here is where we store the destination disk image. So the conversion of for the conversion of VMTK to raw format, we'll use QEMU image tool. So we will, this is the command that we'll use for this. So convert from source format VMTK, this is the source image, output format raw, and this is the target. So let's start it, and it will take less than a minute to do this conversion. Of course, in practice, this process must be much longer, but again, now we have our virtual machine operating at the source hypervisor.
Venko, while we're waiting for the virtual machine to be ready, I just want to mention that we have also a guide on how you can migrate step by step from VMware Hypervisor server to KVM. And I already pasted the link on the chat, so if somebody is interested to have everything in writing, you can also download the guide.
Yeah, thank you very much. So exactly these steps are given in this guide, and we have 3 versions of the guide for the 3 type of source hypervisors. So the procedure is the same, commands would be a little bit different. Okay, so now we have our image transferred to the target image. Our data transferred to our target image. Let's check. We can see now that our target disk def SDB contains some data, and it has definitions for 2 partitions. These are the partitions on the original Windows virtual disk. So the last step is to transfer the snapshot image that contains all the changes made since we made a snapshot until now. So to do this, we need to stop the virtual machine and then copy the snapshot image. So this is the image. This is the image that we need to transfer. But because this image, let's first check, have a look at how this image looks like now. Okay, it's about the same. So we need to stop virtual machine so this image can be copied to the target system without being corrupted. So let's first shut down the virtual machine. You can see this image is much smaller than the original disk image. Sorry. Okay. Again, we execute command on the SSH hypervisor from the conversion host. We could shut down the virtual machine from the web interface, but if we need to automate the process, we will use CLI interface. So with this command, we shut down the virtual machine. Let's have a look. Okay, so the virtual machine is shutting down. It is very important, especially for Linux virtual machines, to be properly shut down because if we just stop them, the virtual machine will leave the NTFS file system in an inconsistent state that will not allow us to do the osmorphing later on. So it is very important. Sorry.
Guys, I will just ask you to mute yourself once again. Thank you.
Okay, so when the virtual machine is shut down, we can copy this snapshot image. Okay, it took less than 2 seconds to copy this. And now we need to apply this image to our raw image on the block device def SDB. So to do this, we will use this sesparse tool. Again, you can find the source code of this tool in our GitHub repo. So the first argument is the snapshot image that you would like to apply, and the second is the destination, def SDB. Okay, so all the changes that were stored in this image are now applied on SDB. So SDB now is the exact copy of the original disk image on the source hypervisor. So the next step is to, so we did the copy the snapshot image and apply the snapshot to the target image. And the next step is do the osmorphing. To do the OS morphing, we need a small configuration. This configuration is used by Vert V2V to get the information about and all the settings needed for the target disk image. So the important part of this configuration, this one that gives exactly where the destination disk image is. And the command to do the actual morphing with Vert V2V is this. So Vert V2V, we are using a version of Vert V2V that we compiled because there are some changes that need to be applied that does not exist in the upstream source. I'll talk about these changes a little bit later. So we run Vert V2V and with the configuration of the virtual machine is in this file, and we tell to do all the changes in place, that is not to create a new target new target image, but to do all the changes in the source image. So this is SDB. So this command will actually create a small virtual machine. We will attach our image to this virtual machine and will analyze the content of the image. Okay, it detects Windows Server 2019. And we can see it installed VirtIO drivers for Windows on this virtual machine. There are some warnings that are expected. And basically, this is all that we will need to do for this migration. So now we have our image ready to be started on a KVM hypervisor. So to do this, we need to detach this drive SDB from our conversion VM and attach it to the target virtual machine. So we can do this in OpenNebula. Okay, this is our conversion virtual machine, and we will detach the disk image from here. Let's give it a few seconds. Okay, go to the list of virtual machine, and this is our migrated virtual machine, and attach the same image here. Okay, so we have this image attached. I check the configuration. Yeah, it looks okay. We have the same settings, network interfaces here, storage devices here. So we are ready to start the virtual machine. Okay, let's start it. So it will take a few seconds to start the virtual machine. Okay, let's see if we'll be able to. Okay, Windows operating system is now booting up. Let's give it a few seconds. Here it is. Let's try to log in here. Okay, so Windows may give us a few warnings that it needs to be restarted because there are new drivers, and Windows would need to initialize these drivers. However, we don't have to restart this Windows virtual machine anymore. So for example, you can see that the network interface is still down. In a few seconds, the driver will be activated and the network interface will go up. So here are the warnings that I told about. Yeah, and the network interface now is up and running. So we may get a few more warnings like this for the other new hardware. Let's have a look how our hardware looks like. So we have two processors. Okay, the processors are a little bit different because this is a different physical hypervisor underneath, so they expose a different physical CPU. But again, two virtual CPUs, 4 GB of RAM, and in the device manager. Okay, let's check disk drive, QEMU hard disk SCSI device, and it is connected to the, let's see, the SCSI controller. Now it is Red Hat Virtual SCSI pass-through controller, and the network device, Red Hat Virtual Ethernet network interface. So all our drivers are updated and active, and we can use our new virtual hardware here. So our virtual machine should be fully functional now. Let's check the network. Okay, and okay, we have access to the virtual network and to the internet. So with this, our migration process is completed. If we automate these steps, we'll have only basically 20-30 seconds of downtime while we are doing the OS morphing. And as you can see, we can use any Linux tool to automate this migration process. We can script all the tasks. So yeah, this was the last step. We start the target, the virtual machine on the target hypervisor. So the demo was on VMware, but exactly the same procedure can be done with migration from Microsoft Hyper-V or from Citrix Zen server, and possibly with any other source hypervisor, as long as you can create snapshots in separate files that can be transferred separately from the main disk image. Of course, it will need a tool that will be able to handle this and to process these snapshot images and apply them on the disk image. The tools that we used and that are available for the other types of hypervisors are available on our GitHub repo. So you can find there sysparse that we use today, but also VHDX and VHD2. These are tools for the respective image formats used by Hyper-V and Zen server. And actually, VHD is used by Hyper-V also for some older versions. You can find in this repo also some scripts that automate this process. But in any case, you need to customize these scripts for your specific environment, like addresses, names, the exact order of the tasks, and so on. And on the same repo, you will find the patch for V2V for these Windows guests. Again, this patch deploys on the guest operating system the keys that are used to sign the Virtual drivers. Without these keys and without this patch, Windows will not be able to use installed drivers. So,
thank you, Venko.
This was the demo. Yeah, let's see if we have some questions on the chat.
It was really, really useful, and we also get a very positive feedback during your talking. So thank you once again for the detailed presentation. Now I'm going to the questions part. I will start with the questions on the chat, and if somebody wants to unmute yourself after I finish with the questions on the chat, you're free to do it. So first question is, how stable VM will work without appropriately injected Windows drivers?
Sorry, without properly
Injected Windows drivers.
So this is part of Vert V2V project, installing the drivers in Windows, and it is used in many migration projects. It's not only with this is not something that we have invented or we have developed. So it is widely used, and I would say that because of this, any problems should be already be solved. We are not aware of any problems with this.
Okay, and there is another question in regards to the Virt V2V. What changes has Torpool done to Virt V2V?
Okay, I think I already answered this. So the changes are installing the keys that are used to sign VirtIO drivers by Fedora. So these are Fedora public keys. Because these keys are not recognized by Windows by default, and this change uploads and register Fedora keys, so Windows can trust Fedora drivers and can install the VirtIO drivers by Fedora.
Okay, another question which I see on the chat is how you measure downtime. And I think we actually mentioned this maybe on the first slides of the presentation.
Let's go here. So this is, I will go on this process. This is from the the downtime. We measure it from the time we shut down the source virtual machine to the moment when we bring up the target virtual machine.
Mm-hmm.
So we do not have here any tool to monitor and measure it. This is how we estimate or how we evaluate this this downtime. And the main difference here in this project is that that the longest task, transferring the big image, is outside of this critical time frame when the virtual machine is stopped.
Okay. Another question which is coming from our Facebook stream is how do I build a KVM stack and what orchestration should I use?
Well,
would you like to answer it, or we also have our chief product officer who is part of the webinar and is hearing, so maybe he can also help?
Yeah, it is a very generic question. Probably Boyan could give a better answer to this.
Hi, Boyan.
Hi there. So you hear me, right?
Yeah.
Okay. So how do you build? What orchestration should you use? It depends heavily on the use case and on your familiarity with a particular tool. So if you're familiar with OpenStack, you could use OpenStack, for example. But it depends on are you an MSP, are you a private cloud, what features you expect out of the orchestration, and kind of the good thing about KVM and also the bad thing about KVM is that there is choice. There are multiple competing projects in this area.
Okay, thank you, Boyan. Anyone, do you want to unmute yourself and ask a question? Because I have two more questions from the Facebook stream, but if somebody from here would like to ask a question. Okay, how to migrate 1K plus VMware VMs now? Would you be busy for 3 months then? If you have Venko, let's say 1,000 VMware VMs, do you think it's gonna take 3 months?
Well, every project is different. The most time-consuming part of the project is the preparation stage. Typically, the project looks like this. We need to identify first what of all the stuff that we discussed today need to be migrated. Do we need to migrate only the virtual machines and the virtual machine and the disk images, or we need to migrate integration and some services and some other configuration that are specific to the source virtualization platform. Then we need to identify how we can migrate each of these different resources. Now we discuss only the virtual machine configuration and the virtual machine and the disk images. But other resources also would need a proper planning. And when we are done with this, then typically the next step is to prepare the system, port the configuration to the new system as much as possible. Maybe one of the difficult tasks here is to to connect different sets of virtual networks on the source system and on the target system, so you can operate during the migration time frame, because some of the virtual machines will be still on the source system, and some of the virtual machine will be already migrated to the target system, and they need to share the same virtual network. So this is one of the difficulties in this migration project. And when you solve all these tasks, you typically start with some migration of some test virtual machine, and then with this test virtual machine, you tune your scripts for migration. This typically takes a couple of days to tune your migration scripts. When everything is ready, you can start with the less critical virtual machines running through these scripts, and you'll see actually if you have any problems with the production virtual machines or not. So you can address this as early as possible. And then you start the mass migration of the rest of the virtual machine. So running the script itself and do the actual migration could be very fast process. It could take, let's say, a couple of hours or a couple of weeks, depending on how long it takes to transfer and how big is the cluster and how big is the storage system that and the data you need to transfer. But the most of the time is spent on the planning and testing the procedures and preparing your migration scripts. So I would say this is mostly a system integration job than operations.
It sounds like you really need to have a good plan in advance.
Yeah. Just one thing on this question, that
yeah.
I'm trying to read the subtext of this question, and I think something that needs to be made clear is that what we showed on the webinar is how to manually perform the steps, while in a real migration projects, all the steps that we showed would be automated. They would be executed by a script. And in the GitHub repo, there is also a script that does this, a script that kind of does exactly these steps in sequence. So you don't need to kind of create a snapshot, stop the VM, copy the image, etc. Right? So it's not like a half hour per VM. It's just a minute per VM or less, right? So it depends on how much data there is to copy only.
And another question is Torpo offering such kind of migration projects? So
generally, our focus as Torpo, our focus is on primary storage systems, right? We're a storage vendor. We are sharing these open source tools and the information in this webinar because of some experience we've had with our customers migrating from various hypervisors to KVM, right? So we've gained some experience in that area. We may assist in such projects as a professional service, but it's not the focus of our company.
Thank you, Bojan. Anybody else with any questions? You can ask now because we are going to the closing of the webinar. If we don't have any questions anymore, I will just say a few closing words. First of all, applause for Venko, and thank you very much for the detailed presentation. Everything went very nice, and I'm pretty sure it was useful for the people who joined. We will send you the slides from the webinar, and if you want to get the on-demand recording of the full demo, you can ping me at ip@storpool.com. In addition, I mentioned for the guide that you can download the step-by-step guide so that you can read it when you have time, and also you can track the next events which are upcoming for Storpool. We have a Cloud Infra Cafe, which will happen on 28th of May. You can see the information on our website, storpool.com, for the people who are interested to learn more about OpenNebula, which demo was using, Venko was using, sorry. On the demo, we will have also a webinar with our partners from OpenNebula on 26th of May, and we will talk for migration to OpenNebula and Storpool storage. The Cloud Infra Cafe, which I mentioned earlier, is a more free format. It's an open discussion, and the next topic is which As the service use cases are growing in the times of the coronavirus, and we hope that you're all staying at home and feeling good, being healthy. Thank you once again for joining the webinar. Don't hesitate to get in touch at info@storpool.com and ip@storpool.com, and have a great evening from us. Bye.
Goodbye.